Evaporation. So why does evaporation occur? Let's use water as our substance and think of all the water molecules in a glass. Now, as they're exposed to heat, some of the molecules at the surface gain enough energy that they have enough energy to escape the intermolecular bonds between the molecules, and they go to the gaseous phase. So evaporation is when a liquid changes to a gas, and it happens at the surface of your substance. So it's the change of phase from liquid to a gas, and it only happens at the surface of the liquid. And that's an important little bit, so let's highlight it. And only at the surface. Oops. Back away. All right. So evaporation is that change of phase from a liquid to a gas. And this is just another picture to show you, so it says the same thing. You have warm air moving over the top. That warm air gives the heat or the enthalpy to the water molecules. They gain enough kinetic energy, remember that term, energy of motion, that the molecules have enough energy to escape from the rest of the water molecules because they have an attraction for each other, and off they go to the gaseous state. Evaporation can happen at any temperature. It happens more slowly at a lower temperature and more quickly at a higher temperature. In evaporation, the faster molecules leave the liquid. The average kinetic energy of the liquid decreases. Now remember, kinetic energy is the energy of motion, and you might remember that temperature measures the kinetic energy of the liquid. So because the kinetic energy decreases of the liquid that's left behind, the temperature decreases. So I have written, remember that temperature measures the kinetic energy of the substance. Now, one use of evaporation to cool things is by canteens that are covered in either canvas. So the canvas is this old style one. If you ever go to Army surplus stores, you might see those, or there might be one around the house. Or a canteen that's covered in, that is like a wool felt. When you get either the canvas wet, so I'm going to say canvas here, canvas, or you get the wool wet, as the water evaporates, it takes energy to evaporate, so it keeps your water cool in your canteen. When we sweat, the energy comes from our body, so it actually cools us down because it's removing some of the heat energy. Some animals don't sweat. So here's a puppy, happens to be my puppy about 6 years ago, and it was a very hot day in Napa, and he just made himself at home in the water fountain because puppies don't sweat, dogs don't sweat. They use their tongue, so when a dog is panting, that's how the water is evaporating from the animal, and that's how they cool down. Pigs don't sweat, so you'll see pigs, if you're ever around a farm with pigs, wallowing in the mud, and that's one way they can keep cool. Now sometimes you have a solid that evaporates, and that's termed sublimation. And sublimation is when your solid turns directly to a gas, and there is no liquid phase. The reason for it occurring is when the vapor pressure is higher than the atmospheric pressure. So that means your vapor pressure of your water vapor from your, say, ice crystals is higher than the outside air pressure, and it'll go directly to a gas without melting. So I'm going to add no melting. So it's a special situation. We know that snow sublimes, so you can just say snow sublimes. There's a verb. So when we have lots of snow out and you can watch as its depth decreases in the springtime, much of it is subliming. You'll see some puddles, maybe a little runoff, but most of it just goes straight to the gaseous phase. Another substance that sublimes is carbon dioxide, which is dry ice. So dry ice, you could write CO2 if you're familiar with carbon dioxide, or you could write carbon dioxide. Ice also sublimes. If you've ever put ice cubes in the freezer and then maybe forgot about them, or they got way to the back, and you look at your ice tray and you're like, there's hardly anything in there. So they freeze, and then they've been left there so long that the ice has just turned to a gas. It's sublimed. And that's the end.